Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to discuss about a contiguous memory problem that is known as fragmentation. What are the types of fragmentation and how fragmentation can be improved with the result of memory allocation in a contiguous and both non-contiguous memory. Whether in the contiguous memory allocation we use the first fit, best fit or worst fit algorithm, there will be a problem of fragmentation. Fragmentation or external fragmentation to be precise occurs when the division of the memory left the free available memory broken into smaller pieces. Now when the processes are left with memory, they can be anywhere on the memory and thus they are forming a smaller number of larger wholes. But in the external fragmentation, they are producing larger amount of or larger number of smaller wholes, where it can be put together to make it a large block of memory, then they or other processes can run on that system. External fragmentation exists when there is a free available memory space but that are not contiguous. That is, there are amount of available memory space which is enough but that cannot be allocated due to they are not together and placed in different parts of the system. In the worst case, the external fragmentation can go a veering out of control when there is blocks and free space between every two processes of the system. Now the external fragmentation is depending upon the first fit or the best fit, but both the algorithms are same over left with the external fragmentation. Some operating system provide using the first fit, some provide using the best fit. Another reason of the external fragmentation is in which end we should allocate the memory. That the available memory should put into the top of the list or the last or bottom of the list of available memories. So this way the external fragmentation can be defined. Now whenever we're using the first fit, best fit or worst fit algorithm, as we know, external fragmentation is still a problem. Depending on the total amount of memory storage and the average size of the process, the external fragmentation can be a minor or major problem. Now, instead of using the first fit and best fit technologies, we can see that the researchers and the statistics which is used these systems tell us that if there is n allocated processes, then another 0.5 n allocated blocks which are just used for this external fragmentation. So 1/3 of the memory just wastage out because of this augmentation. Now this one is known as 50% rule. The fragmentation can type of both external and internal. Suppose we want to allocate a process of 1800 and 462 bytes and the available memory is 1800 and 464 bytes of a single whole. Now we can allocate the process into that whole with a leftover of 2 bytes. Now the keeping track of this 2 bytes of memory is a pure overhead when we consider that it is larger than the whole itself. So to remedy this solution, we partition the system of memory into fixed partitions, where a process can be restored among its usage and the fixed partition size. If the process's size exceeds slightly by the fixed partition size, then the problem is of internal fragmentation and the difference of memory is defined as so. That is, the partition or a free up of memory is partitioning to the internal of a particular whole or block. One solution of the fragmentation problem, precisely an external fragmentation problem, is compaction. In this compaction technique, we combine all the free up available memory into a larger piece of code that is known as a whole or a block. Now the available processes which are waiting in the input queue can be run executing in that part of whole. But at the static linking and loading, which is done at the load time or the compile time, the compaction is not possible. The compaction is possible only during the execution time binding technique. In execution time binding, the dynamic linking of the shared libraries or the library routines that are to be needed attached to the processes can be done with the help of compaction. Now, where dynamic relocation is possible, it only needs relocating or moving the address and data associated with the program and the program itself, and changing the address of its base register to signify or authenticate that the register's address has been changed, and new moved address so that the compaction is possible. But whenever compaction is allowable, we must determine its cost. In the simplest process of compactions, all the process that are available goes in one end of the system and one holes that are available goes in the other end. So at the other end, we will have a larger freed up block of memory systems. But this procedure is expensive as it requires searching for all the holes and all the available memory and also moving out in the opposite directions. Another possible solution to the external fragmentation is to permit the logical address space of a process become non-contiguous. That is, any process can be allocated to any free available memory that is between the system, so that the process blocks are scattered using the system monitor. Now, this can be done with the help of two different methods, paging and segmentation. And these combined methods can be help to the external fragmentation problem solving also. So, as per we know and discuss this fragmentation, it is a general error or general problem that will occur whenever we want to manage the blocks of the system of memory. So, this fragmentation problem by compaction, segmentation and paging should be addressed by the memory before going or execution part of the processes. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.